Hello, everyone. Welcome to this week's podcast broadcast of This Week in Science. We are here to talk about science yet again, another week. Justin has more art behind his body. He's like so hot. It's like the sun and Mercury and Venus all in one over there. That's new art. This is great. Okay, it's time for a show. So we're going to do that now, and then we'll be done with the show. But you're going to be here in the middle, and we're going to talk about science.
Right.
Yes. Yes. Blair, Justin, and I like to talk about science sometimes every week on Wednesday, 8 p.m. Pacific time, 5 a.m. European Central Time, whatever it is. And, Mastodon will not load tonight, so I'm just going to close that. I got my Discords, got my chat rooms. Everyone's happy. The audio's good. We are ready to begin the show. A little bit late as usual, but it is time to begin the part that actually starts the show. Everything else is edited out, and this begins the podcast. Thank you, those of you, for joining us live. In 3, 2, this is TWIS. This Week in Science, episode number 988, recorded on Wednesday, September 25th, 2024. Slap Fight Science Night. Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with a slap fight, cannibalistic queen ants, and mile-high microbes. But first...
Disclaimer. Much of the world is hidden away. We only see what we can see. And while seeing is believing for some, the eye can be tricked. Belief can bias the eye to see things that are not there, and not see things that are clearly visible. In science, things are often not seen, but observed. Observing is a skill that requires more than light and shadow. It requires a careful awareness of your biases, a knowledge of observer limitations, and the ability to look beyond the surface to see what is hidden beneath. Science is a method of finding hidden away things, of our understanding mechanisms and features of things that live in darkness and cannot be seen by the naked eye. This is where our understanding of germ theory, gravity, electromagnetism, general relativity, chemistry, atomic theory, archaeology, genetics, and evolution all come from. This is how medicines are discovered, how technology works, how our history is known, and how we are now exploring the universe. All of it possible only because we have done more than look. We have observed, and we have listened. To This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone else out there. Welcome to this episode of This Week in Science. We are back to talk about science as we do on this show called This Week in Science. What happened this week? Well, we're going to talk about it. Not all of it, but a lot of it. We're going to explore. We're going to have questions. We're going to dive into uncertainty. Yes. Are you ready?
Let's do it.
So ready.
So ready. Oh, good. All right, everybody. I have stories tonight about hot magma, venomous snakes, climate history, Bronze Age cheese, virtual fish maze, slap fights, and the man cycle. Justin, what did you bring?
I've got inverted genes.
What?
2,000-year-old GPS, mile-high microbiota, and weird web finds.
Worldwide Weird Web. Blair, what is in the
Yeah,
animal corner?
Internet or spider? I guess we'll have to wait to find out.
James, actually.
Oh, excellent. I brought tadpole poop, cannibal ants, and an energy company.
Okay, Blair has started an energy company. That's good.
No.
No.
In
And she-
Atlanta. No.
And she has plants. Yes. Yes. All right. Well, we are looking forward to all of these stories. I can't wait to talk about all of them. I look forward to all of your thoughts out there as you are listening to, watching the show. I want to hear what you think about these stories. Let us know. We are live on this show every Wednesday, 8 p.m. Pacific time on YouTube, Facebook, and Twitch. Yeah, the old school Justin TV, but it's not Justin TV. It's the Twitch now, owned by the other AMA thing now. And anyway, you can find us those places. And that's where shows of the live recording are held for your viewing pleasure. But the podcast can be found all places that podcasts are found once this show that we're recording right now is edited and posted up in the podcastiverse for your subscriptional happiness. And if none of that works for you, head over to twis.org. You can find show story links and other information, and hopefully that'll help you all out. Okay, you ready to dive into the science, everyone?
Never end this show with just having listened to the show. If there's something that captured your interest,
Where will it?
those links, you can read more all about it.
Where will it take you? Where will we go this time? You ready to dive in?
Let's do it.
Yes.
All right. So the stories this week I'm going to start off with relate to it's Climate Week. Well, it's already a week of climate. It's always a week of climate. The climate is the climate. You know, what's the climate where you are? Well, there's a global climate. There's a local climate. Climate. Researchers just published a study in Science of their work looking into what is called the era of life on Earth. What is an era called the Phanerozoic. Covers the last 539 million years. The last 66 million of which is known as the Cenozoic era, beginning with that wonderful time in which the dinosaurs died and then the birds and the mammals became the dominant life forms, well, except for bacteria and plants and other things like that, and insects. But anyway, the dinosaurs, they turned into the birds, and then the mammals were like, yay, let's make humans. And that was it. That's science. That's evolution. But it wasn't like, oh, we all lived in the same apartment building in New York City for that whole time over the last 66 million years, or even that all of life lived in one little tiny place on planet Earth for 539 million years. No, there was all sorts of stuff happening all over the planet, and there were continents on the planet that moved around the planet during that 500 million years. So, speaking of climate, it changed a lot over the last 500 million years, and we've done many reconstructions and simulations of our historical climate record based on ice cores, rock cores, bones, and the isotopes that come from things. So going back far, we use oxygen isotopes to get back up to like 539 million years ago. More recently, we use carbon and nitrogen isotopes, but there's different elements and the isotopes of those elements that have been used throughout our scientific history to be able to more and more accurately pinpoint what things were like at certain periods of time. One of the things that we've been able to take a record of that they were able to look at was like, oh, temperature. Let's do that. Let's see how temperature shifted over the last 500 million years. And then they're like, oh, carbon dioxide. Let's look at how carbon dioxide shifted over the last 500 million years. And we've done this before. But the interesting aspect of what is different about this work, they have taken a number of models and estimates and taken all these snapshots of history from around the globe over that represent the last 500 million years, and they've put it together into their new record that they call the FAN-DA, which is the Phanerozoic distributed record. I don't remember, but it's some kind of, the DA stands for the record type that they are calling what they've done, the modeling that they've done. And what they have seen over this 485 million history is that, yes, there's been lots of change, lots of ups and downs. We thought that there was a lot more cold going on, however, and they looked at the proportions of different kind of temperature ranges, and they found that from transitional to warm, those represented the majority of the historical record on our planet in terms of temperature. They also found that this historical record, their new record, was able to deal with a lot of the uncertainty that had been prevalent previously in the models, and now they were able to test it against the more recent 66 million year old record of the Cenozoic, and which is very consistent, has a lot less variability with it. And they were like, okay, we know that has a lot less variability, so let's test our new model and see if it lines up with the Cenozoic stuff, and it does. So they're thinking that their whole historical record is a lot more accurate than what has been previously. Are there any big surprises? No, not really. Basically, it's been a nice temperature range on the planet. The poles are probably responsible for a lot of temperature variations on how things are working. The tropical areas have gotten really, really hot historically, up to like 47 degrees Celsius, which is almost like 107 degrees Fahrenheit. The researchers, looking at all this data and then comparing carbon dioxide, they do say that they see a very, very specific correlation between increases in temperature, increases in carbon dioxide, decreases, same thing, except for a couple of time periods, which the discrepancy has shown up over and over again in other measures. And okay, they don't have any reasons as to why those discrepancies occur in this study. They can't explain any of that. But they have some really fun data related to the Earth's surface temperature history, much more accurate than it's been previously. The big thing that researchers are saying is something we should be thinking about is the fact that the forcing or the variability of climate shifts, and so a doubling in carbon dioxide and how many degrees of warming that means. Currently with the IPCC, it is suggested that a doubling of carbon dioxide would lead to 2 to 5 degrees Celsius warming globally as an average, whereas the variability they see in this study is about 8 degrees Celsius, which is a lot more than all the models that we are currently looking at suggest. So what does this mean? Nothing new. Really, it's just, again, another piece of data, more accurate representation of the history of our planet, so we have a better understanding of where it's going to be going in the future, hopefully.
So, look, for 47 degrees Celsius is like 116 Fahrenheit. If that's that was a global average at some point. That's above the threshold of a lot of bacteria.
And what they suggest is, they suggest that the bacteria and things living in the equatorial regions, the tropics, probably either left or adapted for very extreme high temperatures.
Wow.
Mm-hmm.
Over a long period of time, which we are not giving them the way that we are creating climate change quickly.
Yes.
But also that chart that you had up there made it look like our global temperature was almost the coldest it has been. in history. Actually, it looks like there's the Cenozoic looks like it's got quite a bit of.
So just to remember, the Cenozoic era is 500 million years, and the
Well, the Phanerozoic,
Anthropocene
No,
epoch.
it's 65.
yeah, the Cenozoic is
Oh,
65,
sure,
66 million. The Phanerozoic is 500
There's
million.
yeah.
Yeah.
But the Anthropocene, which is the
Mhm.
epoch that we're in, that it is
Mm.
influenced by humans, even at the most generous, is 2.6 million years. So
And
little
they then and in this study, carbon dioxide is definitely what appears to be the most important factor. They suggest explanations for the discrepancies in temperature and carbon dioxide, which might include shifts in the continents and the location of like water on the planet, as opposed to heating the orbit of the planet and the rotation of the Earth ending up heating land versus heating water. And water has a higher heat capacity, so that could have taken up a lot of the influence of the sun heating our atmosphere and our planet over, I don't know, millions of years. We should be, over the last of the Cenozoic era, specifically, we should be seeing a big influence of solar heating, because the sun has been, over the 500 million years, the sun has been getting bigger, this getting hotter, all the radiation is getting more on the planet. We should have a lot more influence of temperature from the sun right now, and we don't. And so what's happening there? Is it methane? Is it water vapor? Is it what's happening to keep the influence of the sun relatively stable over time? And they don't have a good answer for that yet. But carbon dioxide, woohoo, everybody! That's something we can influence. So let's do that.
the cool thing about the carbon in the atmosphere too is, depending on what study you're reading, they can actually test the carbon isotopes that are found in like cores and stuff like that, and you can actually see the difference between carbon cycle carbon dioxide and fossil fuel burning carbon dioxide based on the carbon isotopes found in the core. And so you can see the direct blip in carbon dioxide increase during our existence since, like, the 1850s or whatever, as specifically fossil fuel burning carbon dioxide. So there you go. It's pretty cool.
It's very specifically fossil fuels. I mean, and the time scale for these graphs that come with this study, the epoch that we're in right now that you were talking about, is at the very, very end of the, where it's not zoomed in enough to be able, the figures are over a much longer time period. And yes, our temperature is higher, is at a very, very high point right now. So is the carbon dioxide. It's all great, everybody. Let's fix it. We can do that. And I think that's one of the big things about Climate Week this week, is a lot of people are in New York City right now talking about solutions, talking about new technologies, talking about amelioration, adaptation. What resourcefulness and resilience do we have as a society, as culture? How can we do that? So,
and I will say again, if you live in the United States, there's a big ol' election coming up, and I'm not saying how you should vote, but if you can look at who is a climate-friendly politician on the ballot, or who is the most climate-friendly or the most fossil fuel unfriendly individual on the ballot, consider that. There's also going to be a lot of local and state things on the ballots that are directly related to the reduction of fossil fuels, the increase of public transportation options, and other ways that we can try to make these large scale impacts that only come around, at least in the United States, every 2 to 4 years. So there's a pretty big opportunity for us to come out and speak our voices for climate action in that way.
Maybe.
speak with your votes.
Don't, Justin. Don't do that.
And
I have to.
Everybody check
I have
to make sure that you are registered as a voter, because voter rolls have been updated, changed. There have been lots of issues. Don't get to the ballot box and find out that you're not able to vote. Whatever way you want to vote, make sure you're able. If you want to have your voice heard, that is your responsibility. Nobody's going to do it for you, even though, it should be set up so that it's kind of taken care of for you, but whatever.
And but I do want to push back a little bit, because I don't disagree that this is a very critical election for many, 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 many reasons. But our fossil fuel and fracking and drilling and everything else is higher now than it was before. It's not being brought under control, and I don't think it will be by either administration. I don't think that is a focus of United States politics or government, regardless of lip service at the moment. I don't think fossil fuel usage is different. I think it's running itself.
You don't think it's different between the two. You are creating an equivalency between the two sides of this conversation. That is extremely powerful of a conversation to have. I want you to be careful of what you're saying here, Justin, because you do not want to disenfranchise people.
I'm saying that there's terrible people on both sides of this issue.
Make an influence.
Not both sides. There are terrible people everywhere.
I'm just telling you, there hasn't been any kind of a green revolution with either party, and we shouldn't expect one.
That's doesn't mean you shouldn't vote, and that doesn't mean...
I'm not saying don't vote, and I'm not saying it's not a critical election. I'm not saying that you and I don't completely agree on who we would be voting for, but I am telling you on this one thing, I haven't seen it. I have not seen it.
Doesn't mean you shouldn't try to use your influence.
And remember, local elections are often more influential than the national. I mean, you have your vote. Make sure you vote locally.
There are also ballot measures. There are also bond measures. There are lots of things that you can do via voting that can move things in the correct direction for the environment.
Yeah. And we've been talking for years, not just with respect to climate change, but with respect to science as a whole and its place in society, and the fact that it is a civic practice. Science is part of the fabric of our society, and the information that science produces, the people doing science, the technologies that result, all of this, the funders, the funding, the communities are impacted by policies. It all ties together into a great ecosystem that involves science. So we cannot take science out of society. It is a part of our civic fabric. Don't argue with me. Okay.
But I'm also like, this is the last thing is like, it's not a US thing. It's a global thing. There have been a lot of talk. There's been a lot of talk, a lot of conferences, a lot of speeches, a lot of words thrown at climate change. There has been almost no action.
That is not
globally.
True. That is not true. That is not true. That is not true.
My goodness.
The main proposals, the commitments that nations have made have not been met. They have not been.
So that doesn't mean that there has been no action. There are people, communities, there are organized
I'm talking about on
the yeah.
I'm not talking about it on a local level. I'm not talking about, there are of course incentives to make things more energy efficient, this sort of thing. If you're talking about saving somebody a business money, then yes, they will get behind it. But all of it, like they were proposing to plant more trees than there are land as how they were going to commit to
that is cherry picking. Totally unrelated to what we were talking about. This just all I was trying to say.
It's fair. It's fair.
I was trying to infuse some action into this conversation, and the fact there is a golden opportunity as a member of society to make your voice heard. That is all I was trying to say. And there are things that can come out of this. If you look at how politics talked about climate change 4, 8, 12 years ago, they didn't. So the fact that it is part of the conversation and
Mhm.
that
People are talking
politicians
about it.
do have to listen to their constituents about things in a way that they didn't have to before. People, in fact, are aware of where politicians' money comes from, and that there are more and more people coming from the grassroots areas to smaller offices where large-scale impacts can be made, means that voting is not only a civic duty, but it is, in fact, a large-scale way to make big impact in a short amount of time. And it can make people feel like they aren't helpless in a situation that otherwise can feel that way.
Mhm. And in terms of voting and who we get into office, it's important for how our government functions. If we want to talk about the actual politics or like the systemics of it, the stories out recently relating to during the Trump administration, when the EPA was basically gutted, and many researchers were instructed to get rid of negative language about certain chemicals that were new chemicals being approved. There has been evidence released in the last week that that whistleblowers, that scientists were actually told to strike negative comments. Those comments, when the scientists said they would not do it, the comments were changed by their managers. So the reports were not representative of what the scientists actually concluded. And many times scientists were reassigned to non-influential, less influential areas of the EPA. And
Yeah.
it
And
has
there was
been, and legally it has been confirmed that that is going to be considered, it's going to be considered as basically the managers going after the scientists for not doing what they were
I think it
told.
was the EPA, not the Department of Energy, but the EPA, where they instead of firing people, they were trying to get around that because, of course, it might have been illegal or something. But
They
they
should get
were
rid of
going to
everyone.
move the headquarters to like some small town in Missouri or something, so that
Wasn't
everyone.
Missouri, but they did move it. Yeah, and a bunch of people quit, and they didn't move,
They
and
were going to
it was
relocate everybody for no reason other than to make life difficult for them.
mhm.
Yeah.
Yeah, a lot, and these things happen, and it is a result of voting and who gets into different offices and is able uh, to choose the people who are appointed to different offices underneath them and within the system, and the system changes because of
That's
who is in
ultimately that
office.
is who you vote for.
Yep.
It's the person in charge is usually just a figurehead. It's all the people that they bring with them that really have the impact.
Yeah. But speaking of solutions beyond voting, John Hogan is asking if we think fusion power and desalination of the ocean or ocean water can help climate change in a better way with fresh water. Well, if fusion power actually becomes viable, which there are a lot of companies right now on the small scale fusion, we haven't really seen the large fusion experiments pan out in terms of energy production yet, anything that really is sustainable. But I don't know. There's a lot of hope on the fusion front right now, and the desalination membranes, the osmotic gradients, the different technologies that they're using to allow for desalination are becoming better and better. So, I mean, yes, if we get fusion, desalination will be way easier.
Yeah, although I'm not sure how desalination can help with climate change. It helps with other things.
It'll help with other things. Yeah, exactly. But the technology is there. Human will. We will find a way. And speaking of finding a way, I don't need to do any more flip-flops here to keep this show going, do I, Justin? Somersaults?
So this is I'm actually going to start this story with a couple of quotes. One is from Rachel Shannon, a postdoctoral scholar in hematology at Stanford University, who says, "Bacteria are even cooler than I originally thought. And I'm a microbiologist, so I already thought they were pretty cool." The other quote is from Amy Bhatt, professor of genetics and medicine, also at Stanford, who stated, I remember seeing the data and I thought, no way, this can't be right because it's too crazy to be true. We then spent the next several years trying to convince ourselves that we had made a mistake. But as far as we can tell, we have not. So what's cooler than cool about bacteria and data defying and causing researchers to check, double check, and triple check their data? Genetic inversions. This is when there's a physical flip of a segment of DNA, so that a segment that's reading CGTA suddenly is reading ATGC. So this happens. We've recognized that this occurs occasionally. If it happens in a human, it can actually be a genetic cause for disease. It's one of the causes of hemophilia, where the inversion prevents the mechanisms for blood clotting to be expressed. So it's kind of known that this can take place in prokaryotes. Also, some bacteria it's maybe been seen, but what researchers discovered here is that discovered in bacteria is that these genetic inversions can occur within a single gene and then express new proteins that changes the organism's identity in some way or how it functions. So it's a pretty interesting find as it expands the central dogma of biology that one gene can code for only one protein, and that's what its job is. There are, of course, already sort of some exceptions to this dogma. Proteins that are produced by a gene undergo all sorts of splicing and pre-editing so that they actually can form multiple proteins from a single gene. But until now, no one had seen an entirely new functional gene hidden in reverse. The team identified thousands of inversions that exist in bacterial and other prokaryotic species. So not only a discovery of this single gene inversion that it can occur and be functional, but they actually may be relatively common. The team suspects that there are specific enzymes that mediate this flip, as well as certain environmental cues that can drive the change. So this is something that may be triggered by the environment. We've talked about this to some extent, but this is almost like a real-time epigenetic change, where this protein is not the one I need anymore. Let's do a little switcheroo, and now we're expressing a different protein that maybe is useful. So what the team's now going to do is they're going to start to zero in on the cause and effect of this flipping. Learn hows and whys, the scenarios under which it takes place, specific enzymes that are responsible. If they can track down the enzymatic flippers, they may actually be able to reverse certain heritable diseases. And this sounds like a built-in CRISPRing gene therapy kind of a thing. Like there's some genes that can already do this, that have a mirror function that we just weren't aware of.
So we think that maybe there are just already waiting to be discovered these mirror functions in genes that they're already, that we just haven't seen it. We just haven't looked for it well enough.
Yeah, because they didn't. I mean, it had been noticed for some time that occasionally genes are expressed backwards, and it is just thought, this one has this weird error that took place somehow.
Right, but an error, right? That it's just like it's backwards in the code, not that it's getting actually translated, transcribed, and turns into something.
And now they're like, maybe this is strategy. Genetic strategy. So not only make this like have, of course, they have to go and search for these things, one of the things that they might be able to look at is like, okay, if they can identify specific enzymes that mediate flips, then they can see where are those enzymes present, where might they be able to be present, what genes in that region might be interesting to look at to see if there's a flipped protein that could be doing something. But this also gives us another mechanism. I mean, this is big. This is like another mechanism for evolution, and epigenetics is hidden in this puzzle, as well as all of the protein capabilities that may be already there present in our genetic code, or but just bacteria is what they're looking at right now. But they've it's like a whole new field that is possibly being unlocked by this discovery, which is why they didn't believe their own results. Like this is not in any of the you find a thing and you're like, oh, let me go look for confirming literature. Let me go see where this has been seen before. And when you get to a point where you're working on your research and you can't find any kind of a confirmation for the thing you're looking at, where this thing that you've discovered hasn't been seen before, after tens of millions of researchers and scientists have worked on problems for decades and decades and decades, you go, maybe it's wrong. First thing is like, maybe we've gotten something goofed. They spent years
thinking that it was a goof.
Looking at this and testing it, and they've discovered like, no, what we're seeing is a new thing.
Bacteria, and maybe more than bacteria.
Maybe more than
Genes.
bacteria. Yeah.
And maybe it's a big aspect of evolution. Maybe it's a huge aspect of things switching up, and maybe it's not just single nucleotide polymorphisms. Maybe it's big old gene inversions. Maybe it's gene repetitions and then inversions. Like there are so many ways that this could be. It's fascinating.
And then so downstream from a gene printing out a protein, there's a sort of a pre-cleaving, splicing, and all these like little additors that can happen. So even a regular gene can have different variants and manifestations that do slightly different work in the body. But now if you've got another entire ingredient to start with that you can also splice and edit, and it opens up the ability for this protein catalog of workers in a biological system to have more options. And what triggers those, it's going to be fascinating.
Yeah, I think that's the great, what triggers it, what makes it happen, when it does happen, was it originally accidental and then it just became a thing, and just like every time it's like, oops, happy accident, now that's normal and that's the way it works. That seems like, biology, it's nature's kludge, it's just how it all ends up. That's fascinating stuff. Blair, do you want to take us on a journey?
Oh yeah, to Florida to talk about the energy company there.
Florida, nature's
They're probably
kludge.
fine, right? Floridian energy company, Duke Energy. They're probably up to just generally good stuff, right?
Are they hurricane powered? Yeah.
Yeah. Turns out actually yes. But not on purpose. So this is a study looking at vegetation management that is beneficial to utility companies, and turns out to also be beneficial to pollinating insects. It's the largest scale study of its kind, covering the greatest number of sites and species ever done for something like this. This is from the Florida Museum of Natural History. They surveyed 18 what are called rights of way managed by Duke Energy. So basically what that means is a right of way is where they have like a power line or some sort of utility infrastructure, and they need to mow, use herbicides, or prune in order to create an electrical right of way. And so the way that they do that, they need to make sure that there's no like fire potential for sparkage around the items, that there's no opportunity for it to get, you know, a wire to get brushed up against or knocked down, that there's no kind of reduction in the amount of power getting to those utility pieces. And so that is their right of way. And so when they create those, it turns out that a lot of Florida's insect pollinators actually thrive in these areas that have been trimmed back. Now, it turns out that's actually
Fascinating.
because they actually normally thrive in areas of early succession, which is what happens after a forest fire. So normally
Fascinating.
there's these larger growth areas, there's a lightning strike, there's a forest fire, and then after that, these smaller plants that promote like pollinating insects, they flourish, and then they get outgrown, and then those smaller plants die, and then they grow nice and big, and then a couple of years later there's another forest fire, right? So but because we're on the scene, there are houses nearby, there are developments nearby, and the utilities nearby, we don't want forest fires. So the forest fires are suppressed. And you know, that's like the classic thing about when colonizers came to the United States, what's now called the United States. We stopped doing fires in our forests because we were like, fire's bad in forests, obviously. But
Yeah.
a lot of the native populations here knew how to manage forest fires sustainably. And so because of that, it's kind of thrown a lot of the succession balance out of whack in a lot of forests across the United States, North America in general, I would say. And so now, of course, forestry organizations are doing a better job of controlled burns to try to get back in that space. But again, if you're right near a house or a housing project or a development or utilities, you can't do prescribed burns. You just can't. And so
Poison.
instead, poison,
Yeah.
mowing, or pruning, hand pruning, can still promote these pollinator spaces. And so, yeah, there's all sorts of numbers involved about how to measure this, but the long and short of it is that what is good for these utility company spaces, for the utilities, quote unquote, right of way in these forested areas, it is also good for pollinators. So a rare win-win with industrialization that I wanted to share.
I think it's fascinating. I love the way that it coincides or collides with our understanding of the succession, ecological succession. The whole story is, I don't know, I think it's really fascinating. It's really cool.
Yeah. So there you go. Energy companies accidentally doing good for the environment.
It has to be caveat.
Let's be clear. They weren't like, oh, good, the pollinators. It's like, we got to do it for them. No.
No,
but that's great.
Not at all. Yay, pollinators. Yay, energy companies. And hopefully those energy lines of the future will be even more sustainable, losing less energy. Yeah, well maintained. And maybe they will be transmitting energy produced from sustainable resources. Yay! The crowd goes wild with hope. Let's talk about not, well, I guess it's succession. It's the succession of cheese and the bacteria that are related. This is a cheesy segue from succession into archaeology and genetics. Researchers just published in Cell 50, Open Access Cell Journal, their work on the looking at Bronze Age cheese. Researchers were able to get samples of what looked like fermented milk products, dairy products, from about 3,500 years ago from a cemetery in Zhuanghe, China. And the this data that they collected, they were able to compare the genomes of the milk from the milk to genomes of dairy products from modern goats. And so they were able to go, oh, there were goats back then, goats now, compare the milk and everything. Oh, look, now we're going to compare the bacteria that are involved in these fermented products. They determined that it wasn't just Bronze Age cheese, it was kefir, that the fermented product was most likely a kefir-like substance,
So, can I? This is
which
my
has yeast in it. It's yeast.
Culturally illiterate. What's a kefir?
It's drinkable yogurt.
It is. You can
Oh, what
have
is
it
it?
drinkable. You can have a kefir water. You can have a kefir dairy product. Kefir is usually fermented not just with probiotic, what we call probiotic bacteria now, lactobacillus, but also yeast. There is a whole fermentation process that
Okay.
goes on. And my images aren't coming to the stage. I don't know why. There it is. Woohoo! I got it. Okay. So these researchers looking at Asia, the Central Asia, the steppes into the Caucasus historically, people thought that kefirs and cheese-like substances came from the Caucasus. But apparently, no. According to their research, Bronze Age kefir cheese from 3,500 years ago came from more of a Xinjiang to inland East Asia, that it moved with the Caucasus and more of a Central Asian area being more of a pathway for the spread of kefir over more of the Indo-European continent, but that really kefir spread coastally, and that this kefir, they could actually construct ancient phylogenies to be able to determine how modern kefir relates to ancient kefir. And the really interesting aspect of it, it was pretty much, very much, it just was its own thing in Zhuanghe, because Zhuanghe was a place where they didn't talk to a lot of people, and they had their own goats, and they were like, we have our own kefir cheese, and we're just going to be by ourselves. But then they shared their kefir cheese, and their kefir cheese got shared with other people's kefir cheese, and then it was lots of spreadings of kefir cheese. So modern kefir cheese is quite different from ancient Zhuanghe ancestral kefir cheese, but it suggests also a spread of trade for and culture throughout the greater Asian continent, which is pretty interesting.
Yeah. Interesting. Indeed.
Yeah. Kefir cheese. Thousands of years of kefir cheese.
Is it the
Now you
same kind of like individual line, the lineage of kefir that we're eating today?
It is not exactly the same, no. And but the bacteria, many bacteria are related. There are lots of things that suggest their relatedness to modern kefirs. The locations of these lactobacillus species and comparison to that ancestral Zhuanghe kefir and current kefir stuff. So, yeah.
That's
Mm,
cool.
yeah.
It would have been nice if it was the same. It's like I've eaten that same
It's
Bronze
related.
cheese.
Yeah, no, it's related, but it's not the same anymore.
Because
It
you
has
can use the
changed.
same seed on yogurt for like years and years and years, right? So like
It's not like that. It's not.
it's
It's
like
not
the
like you're.
sourdough mother dough from the Bronze Age passed down.
But that Zhuanghe kefir cheese, it's
Yeah,
pretty much still the same.
there you go.
Old school kefir cheese. That's what it is. You want to tell me about the Nazca lines. Or yes, what's happening in Peru?
Well, sometime around 2,000 years ago, the Nazca and Paracas people living in southern Peru in the deserts got really into making art on a massive scale. They created animals and human-like figures and plants out of gravel and stone. These are called geoglyphs. So these are sometimes raised mounds of earth that are used to make the lines and the outlines. Sometimes it's just stones, maybe specific darkness or brightness of stones that are laid out. Some of these can stretch 90 meters long. You can see them in an airplane better than you can see on the ground.
Right.
And some, I think a majority of them are in the 5 to 10, 15 meter. So something that would be much more easy to appreciate on the ground. So over the past 100 years or so, 430 of these epic scale artworks have been discovered. They are classified into the larger line type glyphs, created by removing stones and gravel to reveal lighter colored earth beneath, and smaller relief type glyphs that are drawn using surface stones, colored both black and white or kind of slightly raised earth. In the big line type, glyphs are easier to spot using photographs shot from the sky, whereas the relief type glyphs, it says here, averaging about 9 meters in size, are harder to see because of erosion and more subtle contrast with the desert terrain. So 430 have been discovered in the past 100 years. Then, over about 6-month period, artificial intelligence was given lots of aerial photographs of the area and identified 303 new glyphs. So almost doubling the extent of our knowledge of this ancient artwork in just a 6-month period. Among the glyphs, about 80% depicted humanoid figures. It says here decapitated heads, but maybe they only wanted to make it, a profile.
They're making a statement to the gods.
Yeah, well, but it could also just be it's a profile picture. It's not decapitated. I just take a picture of the head. That's all I was drawing. Also, lots of domesticated animals, particularly llamas. Most of the relief type drawings were found within the viewing distance from foot trails. Researchers think the art communicated daily life activities for viewing by small groups or individuals. In contrast, about 60% of the line type, the long, big glyphs, depict wild animals such as birds, monkeys, and felines. The team suggests that these were linked with ceremonial pathways and pilgrimage routes. So I think the more practically think about how these might have been useful for people who were nomading about the desert 2,000 years ago. So what you want to do is you want to follow the northern bird wing until you see a pack of llamas. Take a hard right from the third llama there, and what you'll come to a giant monkey. See, you get to that giant monkey, and the path that leads directly off the monkey's tail, that's the one you're looking for. Follow that one, just past the big cats, and there, if you should be right where you're wanting to be. But if you come to a coiled snake, turn back, you've gone too far. These could actually be location landmarks.
Location landmark, I think that's one way, but I like the idea that it could be, we have movies now, right, that take 3.5 hours, right? We've had long stories that we listen to over fires, but during the day, maybe you could go on a walk with a storyteller, your wise person, your shaman, and they take you on a journey, and you see these creations from a distance, and they tell the story as you move through an area, and maybe it was an active co-created storytelling or history telling.
I love that idea. Yeah, like a
Yeah.
walkthrough movie. Yeah.
Right. Yeah. This was a giant picture book, maybe.
I
And it's
love
kind of,
these. These
you
are
know,
excellent.
They're
it's
beautiful.
kind of like also
That's
there's like
great.
gallery art, which is usually different than art that you would buy and put into a home because it's usually of a scale that's massive, right? It can take up an entire wall. Not always, but it can take it. The gallery art can be quite big, sometimes bigger than anyone would actually hang. These are like 90-meter long works of art. Like that's so wild.
I think they're fantastic. I love they're giant. They're incredible. I love that AI was able to do the pattern finding to be able to discover these things and make them more apparent to us. And hopefully,
The other-
This is
we
a
can
perfect
preserve
use
them.
of AI.
Yeah,
I love this
Yeah.
use of AI. This is exactly what it's for, right? This is
Blair
kind of thing that
approves.
you just can't. Yeah.
Blair approved. Also, one of the things I find fascinating about these, for some of the smaller ones, it's not as impressive. But for some of the larger ones, it is really impressive how doing a very large scale work of art. You're not just drawing it by hand, where you've got this perspective that you can sort of see that. Oh, I drew it this side. It was this big, and so I'll do it the same on that. You've really got to like be paying attention over 90 meters of how far you've gone and taking sort of measurements to make sure that you haven't gone too far, so you don't have one leg that's longer than the other leg or what have you. These took a lot of work, and if you there's the map, right? Look at this map. Look at how dispersed these things are. Like they use this desert as their canvas.
I think that's incredible. And maybe they told the story as they went, right? Maybe they maybe there's something to the groupings and where they're located, and like you said, the distance that they are optimally viewed from.
And a lot of these, like they were saying, a lot of these are on or along pathways that were used, sort of ancient roads through the desert. So yeah, you're exactly right. If you were going along this journey, you would have this sort of unfolding series of pictures that could form a story, so that you were telling a story of where you went.
And though they are hard to see now, once upon a time they were probably much more visible and readily witnessed by people passing through.
Yeah,
so cool.
very cool.
It reminds me of how I saw a meme recently about how whenever there's giant feats of art or innovation, we always want to credit it to aliens if it's in non-white spaces, and then to like just general human ingenuity if it's in white spaces. It's like the joke, right? And I think about how this is definitely one of those things that however many decades ago somebody would have gone like, oh, crop circles, they were drawn by aliens, right?
Absolutely. No, people.
No.
It's people.
People.
Yeah.
Oh, that's a cool one. Oh.
Humans leading domestic animals with rope and decapitation scenes. Like just
Sure.
I'm not convinced as I'm seeing a decapitation, but maybe I'm just.
I think I'm seeing a decapitation. It fits with their the sports that they played that were very violent. Involved.
Well, and yeah, I think that's probably the context we're not getting, right? Like these various implements that they have in their hands might lead to the expectation that is a decapitation.
Yeah.
Okay.
Cool stuff. Thanks, AI. Blair's happy with your use. That's good. Speaking of the land and what's on it and in it, hopefully we can preserve these areas of ancient human artistic creativity the work that people did. Hope we can preserve it and keep modern humans from destroying it. Recently, there were some Nazca works that were destroyed by people hot rodding in the desert. So that's not good, people. Your tires are going to mess that stuff up. You got to be careful of the world. But volcanoes do a lot of damage. Volcanoes go and the lava goes everywhere, and they would cover that kind of stuff up if there were a volcano with the ability to cover up the land with lava anywhere nearby. But what about that lava? Where does it come from? Well, researchers forever have been like, oh, hotspots, magma hotspots underneath the volcanoes, duh. And each of those hotspots is like unique and is going to be like, look, I make this kind of stuff and I make this. And so there are unique signatures for these hotspots that are indicative of the region, of the pressures, of what's happening in the crust as that hot magma is coming up to the surface and getting pushed out by those magmatic hotspots from the mantle and onto the surface, where it then becomes obsidian and all that kind of stuff. Anyway, lava. Researchers just published an open access study in Nature Geoscience suggesting, based on their work, looking at a number of hypotheses about where does this stuff come from? Where does the magma come from? Are they unique hotspots? Are they different hotspots? What's going on there? Well, they tested a whole bunch of things and they were like, nope. There is one common magma pit under the crust. There's lots like a magma soup that the magma comes and gets mixed in. And then as it gets pushed up to the hot spot, then it starts to go up and cool. And it is the specific conditions that are present during the cooling process as it gets pushed up to the surface that make the magma to the lava unique. So from the bottom, and then it comes out, goes, and it goes out onto the surface, and then it gets recycled back underneath into the mantle again, and it goes into a different spot. And it's like, I'm unique. And then the magma goes, no, I am the mantle, and you are one. So there is a grouping where the magma gets moved around and mixed, and everything's in this super hot magma soup, according to this study, and that it's the local conditions where the magma is being pushed out that give it its unique flavors. But yes, they call it, what do they call it here? They call it within the mantle, they call it the common magma. So there's no chemical heterogeneity below the hotspots. There is a common magma entity.
Kind of weird. I mean, this is one of the weird things about being on this rocky planet. It just seems so solid to know that we're just floating on melted rock. It's just such
You're like a giant hot lava cake.
Yeah.
Looks like a solid cake.
Hello.
Dip that spoon in. Delicious hot chocolate comes out.
All that hot chocolate comes
so
out.
Intense underground.
It's very intense underground, but yeah, there's a lot of common primordial earth in the mantle still that has been just sitting there and it's waiting to get pushed out into those hot spots where it will become unique and less primordial in the process, and has been over time, more modern, into time and space of flux, magmatic flux. You know what else has fluxed over time and space? Snakes.
How so?
Well, snakes came from somewhere. Yes. A lot of people think that venomous snakes, like the Japanese spitting cobra, and the family, the superfamily, Elapoidae, anyway, that this superfamily of venomous snakes originated in Africa. Well, I am here to tell you, according to a Kansas a University of Kansas study published in Royal Society of Open Science that, oh, no. Those venomous snakes, you want to know where they decided to originate from? Where'd they come from?
Florida. Is it Florida? I'm
No,
guessing
and it's not
Florida.
Australia. It's not Australia, and it's not Florida. No.
No.
I'm out of guesses.
No. You're out of guesses. What about Asia?
Mm-hmm.
Yes. What about Asia?
I mean, Asia's connected to Africa.
It is. It's not really, but kind of. And over
Well,
time, maybe it was connected.
And they once
became less
were. Yeah,
connected,
exactly.
And there was more supercontinenty stuff going on, and
Mhm.
it's very possible. The researchers for this study did an analysis of various snake species that are spitting and venomous and just the ones that we are afraid of. We don't like them, and they did not come from Africa. That's not where they came from. Snakes, snakes. Okay, came from a lot. Basically, everything came from that Gondwana land, supercontinent. I don't know, long time ago. But snakes and the venomous ones, they came from Asia. That's what they've determined.
Interesting.
Mhm. Cobras, spitting snakes, and Southeast Asia, yes, but very much so just Asia generally.
So
That's a big general.
according to Britannica, just to cite my source here, so snakes in general, the oldest known snake fossil is in England at about 167 million years ago.
Well, that's right, Scotland, right?
Southern England, it says.
Yeah. Oh, okay.
Eophis underwoodi.
I love trying to pronounce these species names.
Yeah, but yes, about 170 million years ago. What did the Earth look like then? What did
150
pretty
million years ago?
separated?
Yeah, very separated. Mhm.
Like, yeah, because snakes. Because this is why I looked it up, because snakes are pretty recent.
Mhm.
The sauropsid line of lizards and snakes as we know them today is, like, in the grand scheme of things, pretty new. So it's very strange that snakes are on every continent except for Antarctica.
Yeah.
But that snakes themselves, the earliest fossil we have for that is after everything's kind of settled out for the most part. So why? And
Well,
why
I
are
mean,
there venomous snakes on every continent?
Yeah. Well, because a couple of reasons. One is just that, you know what, the oldest fossil doesn't mean the oldest thing, right? So they can
No, but we're pretty confident based on the family tree of when snakes showed up, based on the sauropsid lineage. And
then the other is some kind of storm thing happened, some kind of floaty thing happened, because the what do you call them, monkeys in South America,
Old world,
are
new
related.
world.
Yeah, they're the New World ones, and they have like
but they're pretty different.
adaptation.
Old World and New World monkeys are very different.
And venomous snakes are pretty different.
But if you're talking about going time, their separation is not nearly as far back as the snake diversification, right? And yet they somehow.
Is that
for this
true?
study,
I don't think that's right.
pushed the not the origin of snakes generally, but these venomous snakes back to about back 10 million years. So what they're saying with this study is that these Elapoideae go back as far as 35 million years, and the fossils that they've discovered and the branchings and what they've seen also including the sister lineage Colubroideae, which is like pet snakes, like corn snakes and the non-venomous ones, that this taxonomic shift would pushed 35 million years ago in Asia, to Africa 30 million years ago, Australia 25 million years ago, and then into the Americas 15 million years ago. So they would have started in the venomous snakes, began in Asia, moved to Africa, down to Australia, and then, yes, they went across the Pacific Ocean, or probably the Pacific Ocean, to the Americas.
And that's not too surprising, because for some reason this is also when the monkeys are moving, I think. But also there was a point when Australia was connected to South America.
Mm-hmm.
This is how we have the distribution of marsupials, which started in South America, moving into Australia, because they were connected through Antarctica at one point.
So I don't think that's right, Justin. I do believe okay. So first of all
of it.
Old World monkeys and New World monkeys split apart about 30 million years ago. So that timeline is way different from the snake timeline we were talking about. Second of all, the thing I was going to say about venomous snakes is that there are different types of venomous snakes. So there are rear fang snakes and front fang snakes. Now, I think this is about front fang snakes, but there's all these different convergent evolution styles of venom in snakes in different continents. So not all of them were a direct descendant from this one origin that this study is talking about. So I just want to clarify that as well. The marsupial thing, Australia's marsupials essentially are an evolutionary dead end that other animals continued to evolve on the mainland. It is island biogeography. So it is not a direct descendant in South America from Australia.
No, it's the other way around.
No, because the Australian marsupials do not have kneecaps. They have all sorts of things. This is like a whole extra thing. We don't need to get into it.
Snakes don't have kneecaps either.
Differently, but I'm pretty sure that we covered it on the show that the oldest marsupials in the record are in South America, and they're the progenitors, I thought, or as I recalled, of the Australian marsupials. At least in terms of this is how we can track it through thus far. Now, if I am wrong about that, then I am wrong about everything. Blair is fact checking me as we speak. This is not fair. I'm getting fact checked, and the other people aren't getting fact checked.
You have the same internet I have, Justin. I don't know what you're talking about.
Well, we do know that over the last 65 million years, Africa and South America were much closer together. They've been steadily moving apart over the last 65 million years. Yes, at one point in time, Antarctica was attached to Africa and or close to, and so things were a bit differently dispersed, and that may have made the movement of different species different at different times. So, yeah. Anyway. Oh, the snakes.
I knew that South America and Antarctica were linked. I didn't know Africa was down there.
Oh, maybe it was South America. Yes, that's what I meant. I'm sorry. I misspoke. I really should not speak about old maps that I haven't studied enough. I can show you pictures.
If we didn't speak about things unless we studied extensively about them every time.
We're looking it up, everybody. What do? I look things up. Yes. I like to look things up. Yes. So there is an image that I've got right now that I'm going to share. It's got an image of we have the different eras. So we get into Jurassic. We have South, probably got the Antarctic and South America.
And that's Australia's lumped into the side
Australia,
of it.
yeah. Over the years, Australia blooped off from Antarctica. Africa mushed into, it was part of, and then came away from, and then mushed back into the Asian continent. Yeah, things mushed, things spread, and now they are where they are. But I think the big story is that Africa and South America were closer together, and also Australia was smushed in there more closely as well, over that period of time. There's some pretty neat images if you want to search up where different bodies of land were at different times throughout the history of the planet. I like doing that. Oh, we're going to look at this fun thing. Here we go. Triassic, Cretaceous, present day. The Cretaceous, 65 million years ago. We've got some good mushing and smushing. Anywho, snakes don't have knees. They haven't had a need for knees for quite some time. I need knees. And you know what? I'm going to need in a few minutes. I'm going to need Blair's Animal Corner to set me straight about some of these animal things that we're discussing. But right now, I want to say thank you so much for joining This Week in Science for this episode. We do love that you are with us for another conversation about the recent scientific discoveries of the week, what we thought was interesting, and also the questions that we have. And I hope that you have interesting questions as well. If you have information, let us know what you know so that we can update our understanding. Additionally, if you like the show, please head over to twis.org and click on the Zillow link, not Zillow. No, I'm not selling houses. Oh my goodness. Click on the Zazzle link if you would like to have a bit of our merchandise. Support TWIS through getting a shirt, a hat, a mouse pad, a notepad, a mug, maybe a beach towel for your Australian beach getaway. I don't know. Maybe you're going to Antarctica for its Antarctic summer. Maybe you need, I don't know, a TWIS tote bag. We've got all those things and more. Lots of TWIS Schwag that you can buy. It helps support the show. Go to twis.org, click on the Zazzle link, and you'll be able to find all sorts of things to wet your shopping whistle. Additionally, we also have our Patreon community. So if you want to support us in an ongoing fashion, head over to twis.org and click on that Patreon link, $10 and more a month, and we will thank you by name at the end of the show. Additionally, there's all sorts of additionalies. I guess the last thing is share the show. Please subscribe to us wherever you find us and share with people you care about because they need TWIS in their life as well. Right now, I'm going to come on back. It is time for Blair's Animal Corner on This Week in Science. Oh my goodness. Let's get the music going. It's Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have tadpole poop. Or the lack thereof. Ooh.
It's better to have a lack of tadpole poop than too much? I don't know.
Depends. In this case, yes. This is a study on Eifinger's tree frog in Japan. Some frogs, their tadpoles are in ponds or lakes or streams. Some tadpoles, they hang out in the collected rainwater in a bamboo stump. And that is the case for these tree frogs. They hang out in these very small, very confined, collected water reservoirs in leaves or trees or bamboo. And so they are really confined and constrained into these very particular habitats for the entire time that they are in tadpole form before they can go up on land and live their true amphibious life. And so Nagoya University researchers were curious about how they achieved this when there was no way for them to kind of dilute or cycle through waste in these confined spaces for months. If they were just pooping in this water, ammonia would reach a toxic level very quickly, and these tadpoles could not survive. So, what were their adaptations that were allowing them to grow up big and strong and turn into full frogs in these confined little water kind of droplet-y spaces?
What were they?
Yes. And so the first one is that they just didn't poop. So instead of releasing waste into their environment, they would just store poop in their intestines for months.
Wait, excuse me? I mean,
Yeah.
people do that sometimes, but yeah,
Not
that's
for
a problem.
months
That's a
without
problem.
ending
That's a
up in the
big
hospital.
problem. Yeah.
But no, I mean, tadpoles, they're not eating very much. They're also using a lot of energy to grow, arms and legs. So, so the waste
They probably
products are
don't have a lot of
good.
weight. Yeah.
Yeah, there's not a lot to eat in there either. So all of that to say, they're storing all their poop in their body, in their intestines. And also that means that a lot of the ammonia from their fecal matter is being reabsorbed into their body, which to another frog would be toxic. So this is the other piece, is that some ammonia is being released into the water, and the ammonia they're maintaining in their intestines is also being released back into their body. And so they are also able to take an amount of ammonia in their body that is higher than other tadpoles could. So they can take what to another frog would be a toxic level of ammonia. However, there are limitations to that. So the first thing they did is they exposed a bunch of tadpoles to different levels of ammonia, found that generally these tree frogs could take more than the average frog, but there were limits. And then the other piece was that they tracked their pooping and they figured out where they were storing their poop. And so all of these things mean that they have both of these adaptations to help them survive in this extremely extreme environment. I will also mention there are some invertebrates that do this. Not exactly, but similar. There are some bees and things like that their larvae will actually store poop in their body. Bees and ants, they retain feces in their intestines, and that's to keep their nests clean, just so they're not harboring like bacteria or anything like that. But those are invertebrates. It's very different. This is a complicated gut in a vertebrate animal, and they've found a way around a very obvious issue related to growing up in a little bamboo shoot puddle.
This is so fascinating. I mean, we use ammonia, right, for our fertilizers.
Mhm.
Ammonia helps to grow our plants. So we can take the poop from things and turn it into fertilizer and help grow stuff. But if we've got ammonia in our system, that's bad for our growth, and it's toxic because the ammonia ends up feeding back into our cells, and like it kills you. So insect or not insect, you have to get rid of the waste, right?
Right.
That has to happen. And it's fascinating that there are some insect species that hold on to it and can deal with those high ammonia concentrations in their tissues. And so there's definitely going to be adaptations metabolically to allow that to happen physiologically. And then that there are differences in these frogs as well. And it's important for this particular species to help with its survival again in competition with other species in the in that niche wherever it is. It's so interesting.
It must be such a relief to finally, like, we're past the stage. We can now get rid of all of what we've been. That must just be.
To finally be able to poop.
Yeah.
Yeah.
Very
The
satisfying.
other thing, actually, I will say, I'm gonna evoke Brian in this, my husband, because I was reading him this story earlier, and he was like, "Oh, I wonder if having higher ammonia concentrations in their body also makes it harder to eat them," which is a great question.
You don't want
So
to eat these frog legs?
yeah, that they could be toxic to eat because they have high ammonia amounts. Like, I think that's really, really good question. Um,
That's
and
really that's
And
brilliant.
definitely worth
predators,
looking
right?
into. Yeah.
Yeah.
Because ultimately, why are they being laid in these very particular spaces? To avoid predators. So, that could be a very cool double whammy that would allow them to make it through to adulthood. And keep in mind now, these two kind of vastly different animals that I've mentioned, the bees and ants, and then these frogs, the fact that they are very different in many ways, but they both do this specifically in the, larval or the young stage of a metamorphosis, is very interesting too, that they have that in
Mhm.
common, that they're specifically holding on to their waste during the metamorphosis, in like the middle of the metamorphosis kind of process, as there's something there. Why is that? Like, would it be harder to do this as an adult and easier?
Probably. Yeah.
Yeah,
They're
before
probably
their body
most
plans
vulnerable.
sorted out, kind of.
Yeah. Is this metamorphosis period when they're most vulnerable because they're not as good at swimming and they're not as good at jumping and getting away, right? So they're limited behaviorally. Not the best of both worlds. And
I think Brian needs to publish. I think that's it's a great
Yes.
observation.
do it.
Yeah, Brian, forget nursing school. Do this instead.
Yeah.
Study ammonia toxicity in tadpoles in Japan.
I mean, that's
Um,
that's a niche for academia. That's great.
yeah.
That's
Perfect.
graduate school right
Yeah.
there.
Uh-huh.
That's a whole
Perfect.
career.
So from one type of waste to another, ant queens cannibalize their sick offspring and recycle them.
Oh gosh. Okay.
Yep. Are you ready? Strap in. So,
Oh, no.
What?
ant queens, they will found new colonies all on their own. And in those early stages, they're very vulnerable to their entire brood being wiped out by disease. And their likelihood of success as a colony is extremely tied to how many workers they can create, how quickly. If they can grow quickly and they have a bunch of workers, then they can establish a colony and survive, and their genetic lineage will survive. So researchers at Oxford's Department of Biology looked at specifically a fungal pathogen that is really good at wiping out ant colonies. And so they wanted to see what would happen when ants get this pathogen, and if there was a clear path to success to avoid this pathogen from just ruining everything for these queens that are trying to found new colonies. So what they did is they infected a bunch of these black garden ants with this fungal pathogen when the queen was trying to establish. Queens cannibalized 92% of the infected larvae, leaving no remains at all. None. Only 6% of control larvae that had not been infected were eaten. Very small number. When it comes to cannibalizing your babies, maybe anything above 0 is a lot, but in the insect world, it's pretty good, 6%. Anyway. So, when they found a sick larva in the brood, they would immediately start eating them. They would spend hours chewing them up until every last bit is consumed. Because remember, this is a fungal pathogen. So if they don't get rid of all of it, the fungus could spread. Where this gets interesting is that they had about 24 hours to get rid of that fungal pathogen. If the 24 hours had elapsed and Then they went and tried to eat the fungal infected ants. About 80% of those queens would die. So if they did it too late, they also would spray infectious larvae with their antimicrobial venom if it was spreading too fast or if they hadn't eaten them in time. Still, about 80% of the time they died. So they did it within the first 24 hours when they were infected, but not yet contagious. The queens did not get sick. Part of the reason they think the queens didn't get sick is that they have a antimicrobial venom gland, which I mentioned a second ago. They kind of sprayed that over the infected guys if it had been over 24 hours. But it looked like the females were massaging it while they were eating, when they were eating the guys within 24 hours. So they think that actually the queens might be swallowing some of the acidic antimicrobial venom to kill the fungus inside their bodies, which is crazy. That's like using
fascinating.
medicine or something. Yeah. Wild. And the reason they talk about recycling in this is that there was a 55% higher egg laying rate following cannibalization. So once they ate all these fungus-ridden larvae, bam, they created way more eggs. So they basically were able to replace the eggs they lost with the energy that they took. So when they start these colonies originally, they essentially starve themselves to raise that first generation. Because remember I said like this colony is make or break in the very beginning. And so they basically just reproduce themselves almost to death. They almost starve themselves to just using all of their body's nutrients to make as many babies as possible. So if you're going to lose a bunch of them, you're regaining that energy, starting over. So that's the recycling piece. So really good, what they're calling hygienic cannibalism.
Hygienic, yes.
Yeah.
Well, they weren't going to be successful young ants anyway. It's good for the colony.
Mm-hmm. And so this has only been observed in queens, but never among mature worker ants. They think this might be because, unlike queens who seal themselves into the nest, worker ants can dispose of infected larvae by carrying them out. So worker ants just kick them out of the nest completely. But the queen is like, give me those sweet nutrients back.
Sweet nutrients. We're not just
Oh, the
going to kick the
insect world
babies out.
is a brutally inefficient model for.
You gotta be. So this is another situation where it makes us feel uncomfortable because cannibalism, we're associating it with things when we relate to humans that is very icky and but just like when I used to work at the zoo and we would feed hard-boiled eggs to the chickens, people would freak out. It's like, no, actually,
It's good for
chickens
them.
will often
They do it.
eat their eggs that are unfertilized because they want to regain the nutrients that they lost. It's pretty normal. So it's reproduction is extremely costly. And so I mean, anybody who has grown a fetus who might be listening can attest to that. So if there's a way that you can regain some of that energy that you lost, that is an important thing to be able to do in the animal kingdom.
Yeah, any way that you can. And we know that like spiders, they'll often eat their mate. We can't do that. We don't want patricide. We don't want, we want to make sure that the success is optimized, right? Or at least in the animal kingdom, evolution favors optimization of success.
Absolutely. Well put.
Yeah. In terms of ourselves and our, our emotional psychological responses to these kinds of nature stories, right? The trauma, the drama of Mutual of Omaha's Wild Kingdom, whatever it is. Thinking not just about the cannibalism aspect, but from a perspective of public health, we don't just kick sick people out of society, right? We
Yeah.
used to have leper colonies,
Well.
and we used to have sanitariums where we still do actually, but more
And we have
often
quarantine.
now
Quarantine is
we
still a thing.
quarantine. Yes.
Yeah.
So it's interesting to kind of think about how we do this, but at the same time, we're not like, okay, we are, I'm not going to talk about insurance and talk about, public health systems and how they're set up, but societally, we are more and more working toward being able to allow everybody to get the most out of life. It is not the way it is. That's not absolutely the way it is, but I think that those optimists among us believe that we can get there, and that one day people will not just die because they can't pay their bills or get their insulin shots or whatever it happens to be.
So the thing I'm finding
We will
interesting about
protect
this
everyone. Yeah.
is this is a strategy that there is a countermeasure, biological countermeasure for with this gland. This is a situation where there's at least an instinctual recognition of the problem and the solution. This is a when I will call a genetic memory, an inherited memory. This is a knowledge that these ant queens seem to have about their environment and the world around them. That is not learned through what we would consider external. Here's some information. I will now pass it on to you because you had no idea. This is what is so fascinating. Is where is this? Where is this knowledge? How is this knowledge captured throughout the lineage of these ant queens? That's passed down specifically to the ant queens because they, again, different behavioral than you said the workers. So whatever that is not inherited there and is not their genetic instinct. Like the whole concept of instinct itself to me is very fascinating. But
so I would wager that if we did a wider study with these ants where you just tested different types of infection, not just the fungal infection, that there would be a higher rate of cannibalization on any infected larva. That would be my wager.
Yeah.
I don't know that for sure, but that would be my guess.
Yep.
Is that the hardwired instinct that you're talking about, Justin, is basically to cannibalize unhealthy larvae. That would be the wager that I would make. But we don't know. We don't have that research, right? But I think that would be a very easy thing to select for ants that eat unhealthy larvae and breed new larvae.
But these are
more genetic code. Their colony is more successful. That trait continues.
Yeah, no, it would be really fascinating to see because to see if there's a difference with the type of affliction, right? Are these ones unhealthy because they lacked nutrients? They were placed in the wrong part of the brood and they didn't get enough access to something of this nature. Or is this specifically a fungal strategy, which is going to spread quickly and affect everything?
Remember that ants are chemical communicators too. So that means that there is some sort of chemical signal. Sorry. There's some sort of chemical signal that she is receiving from these larvae that they are infected.
Yeah, she's not at all blind to this.
Or
the way
that they're
that
infected with a fungus.
Yes.
Right? Yes.
Yes. But then are there, based on which type of chemical signal, are there different cannibalistic strategies? Like this becomes very, very intensely fascinating very quickly.
And apparently there are many strategies, and looking at different studies, doing a Google search just right now, I don't know this. I haven't known this before this moment, but many ants will eat the eggs, larvae, the young, and but necrophagy of the adults is much more rare.
Mm-hmm.
So
Yeah,
yeah.
it's one of those uncomfortable truths that people really don't like to hear about the animal kingdom. There's a lot more cannibalism going on than you might be comfortable with. Happens a lot.
Yeah. It says a study from 2020 suggests that the frequency of cannibalistic necrophagy of nest mates increases during starvation. Who
Mhm.
knew?
Mhm.
Some ants have the behavior very where it's fairly common, and others do not. So it depends on different species as well. And they, from 2020, they say it might be part of the hygienic behavior repertoire. And like you said,
Mhm.
Blair, chemical detection of infections to handle the pathogens before they're able to spread throughout a colony or a nest is important. But yeah, starvation is another reason.
Yeah, I
Fascinating.
will say, I unfortunately am aware that if you have too many mice in a particular area and they don't have enough food and they have babies, they will eat them.
Cannibalism happens a lot in the animal kingdom.
Yeah, it happens a lot. Sorry.
Cannibal Earth. Dun, 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 dun. You're just a protein source. Dun, dun, dun. Oh, Blair, have you done all your animal stories?
Yes, all of it. I'm ending on that. Isn't that fun? Sorry, everybody.
I think, Justin, you might help us digest it a little bit. We're gonna move on to your stories.
Yeah, so this one is about the gut microbiota, and we have talked about it on the show. It has a role in just about everything: digestion, health, cognition. Basically, to recap, your gut microbes, bacteria inside of you, help with digestion, mood, mental health, physiological development, psychological development, immune responses later and throughout your life, sleep patterns, food cravings, partner interest. And they do a lot. So they do a lot more than just live in you. They are you. They're a big part of who you are. One group of bacterial passengers is emerging as particularly beneficial. It's a genus of gut bacteria known as Blautia. Previous research has suggested Blautia can benefit cognitive development in infants and lower adults' risk of obesity and diabetes. Now, researchers are glimpsing another potential benefit of these microbes: helping people adapt to high altitudes. This is researchers from China recruited 45 men to move for 108 days from their homes at around 250 meters above sea level to a town at about 3,700 meters. At high altitude, the men ate similar food at the same time as they had at home, minimizing the effect of changes in diet and lifestyle on the gut microbes. 7 times over the course of the study, the team collected fecal samples from the men and analyzed the DNA contained within to monitor how their gut microbiomes were changing. After just 2 days at high altitude, the men's samples contained fewer kinds of microbes. They quickly became less diverse. But a handful, several of the 20 known Blautia species, went from being very rare to very abundant. The same subset, including a species B. wexlerae, was also especially common in residents of the plateau who had lived at more than 4,000 meters for at least 5 months, some as much as 5 years. What's going on here? So, following up on these clues, the team had subjected mice to low oxygen conditions, something equivalent to if they were living at super high altitudes, but they didn't put the lab there because the researchers was like, I'm not doing that. So they gave them this Bacteria, sort of a probiotic, to half of them every other day. And so hypoxia can trigger immune cells to release inflammatory factors that can cause fluids to build up in lungs, brain, and intestine. This buildup can lead to sickness, headache, nausea, fatigue, sleep disturbances, and these things can come on pretty quickly. This is common to people who are being tourists in Tibet or going up to very high anywhere in the world, very high altitudes.
Yep.
But the Bautia treated mice showed much less of these ill effects, according to the team. Yeah, this also might, they think, explain how Bautia might protect against diabetes and obesity. There were studies involving 400 people in Japan, where the researchers there had found that the more Bautia a person had in their gut, the less likely they were to have either of these conditions.
How do we get it? Can we have Bautia yogurt?
Well, hang on now.
Bautia
Hang on.
kefir before I go. If I'm going to Tibet, can I preload on some high altitude probiotics? Yeah,
that's one of the things that they're talking about. They want to product this into a thing that you give people traveling to high altitudes.
Yeah.
But there's still so much to be learned. It's very ill understood still at this point what the Bautia species overall effects are. It's not been that well studied. But there is also this is a quote from Vanya Klepak-Steraj, a microbial ecologist at Wesley College. Its superpower comes from mediation of the gut-brain axis. Some of the fatty acids it makes, for example, are known to activate receptors in the vagus nerve, which controls and connects to the digestive system, heart, and brain. Because one of the other things they've noticed, this researcher, which was last year in Science Advances, that there, when it was in infants, they had more babbling. There was more. They
had more to talk about. Yeah.
Yeah, they were literally talking, and that talking could also be because this is something that was being talked about in the brain. It's so crazy. Yeah. Or no, sorry. This is another recent. This is a different recent study, and people suggested it can curb development of appendicitis, immune-driven condition there as well. So there's like all these strange potentials. Yeah, infants are more apt to babble and laugh when they have more Bautia in their guts.
So, but you mentioned the metabolic products as well. So we've got, what's being produced. There's some figures here that suggest butyrate, pyruvate, that there are compounds that are produced that might influence the vagus nerve. So even if we can't get the bacteria, can we influence the pathways of the production for these metabolites, or can we influence just supplement with some of these products?
Yeah,
I'm going to take my butyrate supplement for
So the thing with Bautia is that we don't know really its connection to human health disease, and it may not be the important bacteria at all.
Right.
Or at least not operating solo.
Though. Yeah.
Well, it might not be solo. Like this is the one that they've identified, but it could be that because it's bacteria create communities, that its population presence indicates that there's another one that's active. Like we don't have a specific one-to-one mechanistic thing here yet. So I wouldn't call it a probiotic yet. But I wouldn't be afraid of taking it.
Just you don't ever want to take something that could cause disease because you've already got enough, or anything we do in that regard, we could be influencing you're not just, like you said, influencing the one particular species, you're influencing an ecosystem, right? The microbiome. It's a biome.
But in the world of nutrients, supplements, probiotics, and all this sort of thing, like everything that we know is like really limited. Anyway, like what the effect of taking any of these things actually has to a degree, aside from, having, yes, a good diet with certain categories there, that are positive generally. Specifically adding a one thing or taking away one thing, we don't really have a high definition understanding.
Yeah, you don't want to accidentally release cane toads into Australia, right?
Exactly. You might have all the good intentions, but you're going to spend a lot of time then dealing with the consequences. Okay, now, weird discovery on the web. This is the JWST, James Webb Telescope, has discovered weird galaxies that have gas that seems to be outshining its stars. This is from a Royal Astronomical Society press release. The discovery of a weird and unprecedented galaxy in the early universe could help us understand how the cosmic story began. This galaxy, if you're tracking, GS-NDG 9422, seen at approximately 1 billion years after the Big Bang. So we're actually super young. It stood out to the astronomers because it has this sort of odd, never before seen light signature that is indicating that, its gas seems to be shining more than the stars. The totally new phenomena is significant, researchers say, because it could be the missing link phase of galactic evolution between gas and energy being in an area and formation of the first stars and the first sort of then larger formation of galaxy of stars. This is the quote. My first thought in looking at the galaxy spectrum was, that's weird, which is exactly what the Webb telescope was designed to reveal. Totally new phenomena in the early universe that will help us understand how the cosmic story began. That was Dr. Alex Cameron, Oxford University, lead researcher on the project.
That's weird.
Yeah, it's weird. But this is like a beautiful thing about Webb. It is peering into far back into the cosmic history, and it's also like there's going to be a lot of James Webb originating stories coming out. There's the whole Hubble tension thing about the expansion of the universe and what's going on there. And it's finding more of a consistent signature of some of this expansion than other looks. But then it's also like looking further back and seeing formations early into the universe that we wouldn't have expected to have been formed at these points. The knowledge of the cosmos that this one telescope is giving us is replacing knowledge that we have had for decades, if not hundreds of years, about some of the...
And it's exactly what it was designed to do, which is so cool.
Yeah.
Like, it's doing what it's supposed to. It's seeing exactly the stuff that we couldn't see previously, not just the the resolution of seeing so far back, but being able to see through the dust and the gas and being able to get through the hot stuff to be able to see the cold light and be able to just see the energetic signatures of the radio signals that are the electromagnetic spectrum that are out there, the infrared spectrum as well. Like, it's, this is exactly what it's supposed to do. It's so cool.
And I think the reason that the gas is outshining is because they think this is in the midst of an intense amount of star formation in this galaxy, and it has not captured the gas. So the gas cloud is very dense and it's surrounding everything. And so it's basically getting lit up by all these star formations. I don't know if you've ever. Well, I would suspect
Fireworks of
both of you have
stars.
witnessed this because both of you have lived in the San Francisco area, which can be a very foggy place.
Mm-hmm.
But even on a foggy night, if you're walking around streetlights or something else, it kind of glows. It kind of becomes luminescent around light sources, where you can actually, I recall once being living not far from a car dealership that's got like an entire lot of like bright lights that for some reason stayed on all night. And every time there was a very foggy night, it lit up the entire street like it was daytime because it just became super luminescent within that fog. So sort of what it looks like is going on here.
That's exactly what's going on here. And that's the cool part of this is we're seeing it, lighting it all up. We'll see more. I think this is, we just haven't looked at everything yet. This is one. And it's like, oh, it's going to change everything. It's like, well, yeah, as soon as we find a whole bunch of other ones just like it or in similar phases, it's going to do that. Absolutely. Oh, Webb. Doing all the good stuff for our view on the universe. It's so fantastic. I'm going to take us away from looking at space. I want you to imagine being a zebrafish. And I want you to imagine being, yes, you're a zebrafish in a laboratory. And the researchers want to put you in a maze. And the researchers, because you are a model species being used for genetic understanding of the evolution of, the vertebrate brain and abilities, behaviors. Well, yay, zebrafish, they're going to put you like in a tea maze maybe. They want to put electrodes in your head. That's going to make it hard for you as a little zebrafish to swim around and have free reign of the water. Well, what if
Swim in front of an iPad? Is that what's next?
Pretty much. Something very, very much like that. Researchers just published in Cell Reports Methods their new system to put fish into virtual reality.
Mm-hmm.
These researchers are taking zebrafish and they've got them in a very interesting setup in which they have the fish isolated and have them in a space where they can visualize the world around them. There's a digital screen in front of them onto which targets are placed, and the fish is activated based on stimuli to behave in a particular way. He wants to move right or left or move their heads, but they are basically stuck like a rat or a mouse that's having in one of the head devices that holds the brain in place, so they can have their neurons measured. It's very exciting. So the fish isn't actually going anywhere, but it thinks it's going somewhere because it's in VR. And so this research hopefully will be able to allow researchers moving forward to optically and electrically image neural mechanisms for the cognition of space in the model species of the zebrafish. And in addition, being able to do this in a way they can modify genes, they can knock in, knock out, do chemicals in the water, they can do all sorts of things to study spatial navigation and cognition in VR, in fish. I think it's fascinating. And these fish, they're up for an amazing game. The setup, like I mentioned, they have a device that it's like it's a little. The fish swim into it and they get stuck and they can't keep going. It's like they're cats, but they don't have whiskers, and so they swim into an opening and then they can't back out because their gills and their stuff gets in the way. Anyway, they are glued in with dental cement and held in place, and they want to swim. They want to do all the things that they're going to do, while the researchers are able to use infrared LEDs and cameras, optogenetics, optically imaging certain aspects of the brain. They can use electrodes to stimulate areas of the brain to stimulate different movements for the fish. And then they're able to measure the trajectory of the fish because of the VR situation that they are placed in, as they measure the force that's transduced in their device that the fish has swum into on any side. Fishy VR! We all want to do this. Woohoo.
Except for the dental glue.
I know. I don't want the dental glue. Don't put anything on my head with dental glue. Please, no. Justin, have you ever wanted to talk about the menstrual cycle?
No. Well, to be fair, I didn't know there was such a thing.
There is such a thing. We're not going to call it the menstrual cycle, but there is a hormonal circadian rhythm that exists in the male brain and body, whereas women undergo a 28-day long-ish menstrual cycle. Men undergo a daily hormonal cycle. There is a shift in testosterone, estrogen throughout the day, where testosterone is highest in the morning and decreases during the day. There is high variability daily. It changes in women, and in men, it's throughout the day on an hourly basis. Which is fascinating. We've got lots of evidence that highlights this through the years. Researchers just published their work looking at the brains of one man. This is a very, very deep study looking at lots of evidence. They investigated the impact of circadian rhythms on global and regional brain morphology in one male, a densely sampled male. Every day for 30 days, one man came in and had their brain looked at with MRI, and they took hormonal levels. They found that there were changes in the gray matter and the cell bodies and the connections between neurons from morning until night.
We got the
Brains. Oops, sorry.
zebrafish.
I thank you. I was sharing the tab, but I didn't get the right one in there. No. Come on, man. Give me the right pictures. Hold on. I'm having an image issue. Okay, so in the study timeline, the researchers had one guy who was looked at for a month. They looked at behavioral assessments, aggression, vigor, all sorts of things, and how those feelings changed during the day. They took steroid hormone samples morning and evening for 30 days as well. And they found that testosterone was very high in the mornings, and then was very low in the evening. So testosterone's high in the morning, low in the evening. And then moving forward, the estradiol was fairly constant, but also high in the morning and lower in the evenings. Cortisol was also very high in the mornings and really low in the evening. So this swing is that common thinking. You want to like have a cool, calm hangout with your male partner. Well, cool and calm and collected in the evenings for that nice hangout. Dudes, get your stuff done in the mornings. That's the way it works. Anyway, so what happened with the brain? Well, cerebrospinal fluid changed during the day, and also total brain volume changed in this individual over the 30 days. So cerebrospinal fluid was lower in the mornings and higher in the evenings, but brain volume itself was higher in the mornings and lower in the evenings. They found that certain parts of the brain seemed to be more highly affected than others. So the occipital cortex, more involved in vision, was much larger in the mornings and smaller in the evenings. And the striate cortex was, again, larger in the mornings and smaller in the evenings.
So
This was consistent
anecdotal.
throughout the brain. Yeah.
Anecdotal evidence that supports this.
How do you feel? Morning TWIS versus evening TWIS?
Well, it is. No, if you look at radio, when is the most testosterone-driven, aggro, kind of over-the-top radio?
Morning talk, shock jock
Morning
radio.
talk radio.
Yeah.
Over the top. Let's go, everybody. Like, it's insane.
Yeah.
But you don't have like that same kind of drive time radio on the way home. What you get instead is more calm voices.
It is.
Recounting the day's news and telling you what's been going on in the world.
Unless we're talking about like NPR type radio. NPR type radio, though, has an older audience whose testosterone levels have probably already dropped.
but yeah, like that morning talk radio has always been sort of classically, it's like monster car truck show radio programming type stuff in the mornings where people are just being ridiculous. There's extra loud noises. It's just completely insane in the United States, that morning radio. And in LA, this is actually part of why I was kind of interested. I got interested initially in doing radio and studying broadcasting. Was from living in LA and being in the car for so much of the day, and there are pallets of morning talk radio available for you. But everyone is that's one place that everyone was tuned into because your car had a radio and there's just so many channels and you're stuck there back in those days. Yeah. And that was all you had.
But the question here, though, is, why does the brain size change? And we're looking at one male, but it was very consistent in this one male over 30 days. So is this consistent over larger populations of male identifying people? Is this consistent across all ages? Or does it shift as people age? This individual was in their mid-20s. So is it this is a younger male who had higher testosterone in the mornings, and how does this change when people are low testosterone and taking testosterone supplements or hormone replacement? How does that influence and affect, and does it influence and affecting these things evolutionarily, behaviorally, from a cognitive standpoint, though? What's going on? Does it impact? Does the change is this a thing? Number one, is this a thing? And if it is a thing, does it change? Is this part of how cognition is impacted throughout the day?
So it's a 101, and it's the first time, so we can disregard this study almost entirely until they've done a larger replication of it. But what to me, what like the obvious thing that I would first jump to is this is the effect of sleep. This is what sleep does.
But does sleep does the sleep? It reduces so you have lower brain volume, higher cerebrospinal fluid in the brain at night. You go to sleep, spinal fluid goes away, brain volume increases. Is it the fluid pressure that's pushing on the volume of the brain? Is that what they're seeing? What's happening? Anyway, it's interesting.
There's another piece of this, though, and that is that the adult brain is not done growing until the mid to late 20s.
Mm.
So if they looked at somebody who was mid 20s, that might not be end
Yeah.
brain. So
Yep.
they would do better to do this again with somebody at least in their 30s to see if it was the same. Right?
No,
Because
that's a fair
Yeah.
point. Because if there's one thing I wouldn't want to have to base anything off of, it's a mid-20s brain.
yeah,
Get somebody who's at least in their 30s. Come on. Let's have an
Get
adult
a
brain in
younger
there.
brain, an older brain. I trust that's what the brain is supposed to be doing. Mid-20s brain, yeah,
yeah.
unreliable at best.
Oh my goodness.
Oh my goodness, yes. Well, in this particular write-up, there are other studies where they have looked at brains and hormone, and they've kind of started getting into this question of the male hormonal circadian rhythm and individual differences between parts of the brain and those things. But it's an area of research that it's interesting, and we should really be taking a look at. So many questions here as to how the male brain is impacted by hormonal changes throughout the day, and then how that impacts behavior and what's going on, mechanisms, reasons. Anyway, moving on from hormone cycles, have you guys gotten in a slap fight recently?
So,
I can't say I have. No.
Did you know slap fighting's a thing?
Yes, I have seen it firsthand a few times. I've never participated because I don't know. For those of you who are not familiar, it is where two people voluntarily take turns slapping each other until one of them says they've had enough, and then the other person wins.
This is a professional
It's ridiculous.
sport. It's a
And they leave with a
professional.
very red cheek, I would assume, right? That's the whole deal.
It's
It's a
ridiculous.
professional sport.
No, it's not a professional sport. It's not
Yes.
professional. It may be
Yes.
sport, but it's not
There is-
professional.
there
There's
is-
nothing
look,
professional about
People
this.
are paid. The owner, the CEO of the Ultimate Fighting Championship, UFC, Dana White, has a slap fighting promotion company called Power Slap. They've had television shows, the first of which premiered in 2023. 3 seasons later, researchers at the University of Pittsburgh and VA Pittsburgh Healthcare System have taken the videos that are available and analyzed the videos because they saw evidence of concussions occurring in these slap fights.
Yeah.
The rules.
Of course, you're being hit. It's just an open hand
In
instead
the
of a
head.
closed hand.
And there are
You're-
rules, okay? The rules. 2 people, like you said, Justin, stand across from each other, take turns slapping each other, right? Slap as hard as you can. If you're receiving the slap, you cannot defend yourself, you cannot wear headgear, and you cannot flinch. So most people, if it
Yeah.
gets to the point of hurting just too much, that's when they bow out or they fall down, right? They've been hit so hard. So these researchers analyzed 333 slaps. Concussive signs observed after 97 slaps, 30%. 56 contestants were viewed. 44 contestants out of 56 showed at least one sign of a concussion. 20 of the 56 showed signs of a second concussion.
Yeah.
And contestants who
this is
displayed
like-
signs of a
this is a-
concussion lost the sequence 75% of the time.
This is not a sport. This is a fetish.
It
This
is,
is
but people are being
for
paid and
sadistic
people are
audiences
watching.
and masochistic participants. This is
Idiocracy is real.
a violence fetish,
It is.
not a sport.
The bottom line is these are concussions. There's nothing that is allowed to protect these individuals from concussions. People are, signing up to do this because there's money involved. And just understand, as a viewer or as a person involved in it, this is dangerous. Concussions lead to traumatic brain injuries that can impact cognition, can impact personality, and can even lead to death. So there is a lot riding on this kind of a violent fetish sport, and the researchers are. This is the first study of this kind of thing, and it is, yes, based on watching videos of the sport. And they're now working on a study that's using mouthpieces to measure how hard a person's head is being hit. And they're hoping they can actually study this enough to get some safety standards put in. But it's kind of like this, like, you're going in to get slapped in the face, and I don't know what.
Oh, I just invented a new sport. Yeah, one fella puts his hand down on the ground, and the other fella steps on it really hard. Take turns. Oh, it's a new sport. It's all the rage. This is ridiculous. Ridiculous. Stop it. Stop.
Yeah, exactly. So, slap fight science now.
It's disgusting. Like all billions of years of evolution and all the advances in society and the knowledge that we've gained throughout using a brain, and then this is how you've decided to spend your life.
Yeah.
Shame.
My
Your
question,
brain in particular.
Kyle Pettit is saying mouthpiece equals disqualified. So the question is, as this research moves forward, will safety be allowed? Will people be allowed to have a mouthpiece that they can, bite on, so that it, is there anything that they will be allowed to do in the study to protect themselves? Or is it just, this is a slap fight, and that's all it is, and you take it on? I don't know what the rules are. But oh my gosh, before you decide whether or not you are going to take part in a slap fight, I mean, that's a big decision, right? Maybe you should sleep on it.
No, don't, because first thing in the morning with all that testosterone, you'll be like, yeah, bring on the slap fight. Just before you go to bed, decide. That might be, do I really want to get slapped?
You should ask yourself that. But, big decisions, you really should think about them, especially when you're comparing things and trying to figure a deal out. Maybe sleep on it. Researchers just published their work at Duke University in the Journal of Experimental Psychology General, and they used a garage sale, an imaginary garage sale, to study whether it's better to start with a good first impression or end on a good note. They gave people in this imaginary garage sale study imaginary experiment boxes that had unwanted goods, virtual boxes of unwanted virtual goods. And some of the virtual goods that they filled the boxes with were very high dollar ticket items at the top of the box. Others were high ticket items at the bottom of the box. Some of them were more mixed throughout. Some people were asked, which box do you want? Which one do you think is worth the most money? Right away, and other people were allowed to sleep on it and figure out which one they wanted. Unsurprisingly, the psychological standard of primacy came into account, and people asked, right now, make your decision, were more likely to make their decision based on the first things they saw in the box. So if higher ticket items were at the top of the box, they'd say, that's the box that's worth the most money. That's the one I want. And they had a tendency to overestimate the value of the items in the box. Those people who slept on it were more likely to take a more considered view and often picked the boxes that were more representative of that had the items mixed throughout or were mixed or at the very end, the bottom of the box, when in reality, all of the boxes were worth the same amount of money. hypothetically, in this virtual situation. Anyway, it's an experiment that suggests don't make your decision right away. If you have something to think about and a decision to make, you can get rid of the emotions involved in that decision, or at least balance them out a little bit more by sleeping on it.
That's
So
great advice for a lot of decisions.
Yeah.
Yeah.
Scientifically evidence-based now.
Before you send that angry email, just save it to your drafts. Decide in the morning. Your testosterone may be higher, but
maybe you will have a more balanced view of what you're about to embark on.
There you go.
Yes. Stop impulse buying, everyone. Go to bed.
Hey, what are you doing here? Are you still watching this show? Do you know how long this episode has been on?
It's time for us all.
It's time for a nap.
It's time for a nap. I think we're done here, everyone. Yeah? Have we done
I
it?
think just for our audience's sake, so they can get a good night's sleep, we should let them go.
Unless they're up in the morning just like you, unless you need a morning nap as well. And Blair, I do want to say I'm glad that you did stick with us tonight for this very long episode. And I did let it drag out a bit because Justin didn't have a heart out and because this is your last episode for the next 9 weeks.
No.
And yeah. Blair has other responsibilities. So unless we figure out some other kind of interview or recording times for, for separate sections of the show that can be edited into the podcast later, but are maybe live at a different time of day, just with Blair or whatever. Maybe we'll figure it out. But as it stands for the Wednesday nights for the next 9 weeks, it's going to be me and Justin. Or me and someone else, or me and Justin and someone else, or Justin and someone else, or whatever. But no Blair. So everyone, tell Blair you love her tonight before we end this show entirely. And the great thing is, though, Blair will be back for the holidays. Yes. And then back for sure for our 1000th episode, whenever we decide to do that. January, maybe?
I think we should do it on the 1000th episode.
We should. Really?
Or we could do it the 990, whatever, 999th.
You know what? I'm having this feeling like maybe what we should do if we can't figure out the date right away, or like we'll be like, 999, 1001, 1000, and then we'll be like, oh no, now's the 1000th episode, and then we'll do that one as the big one.
Did we do it on the Eve show? I don't know.
Yeah, we'll figure it out. We're going to be making those decisions. Everybody let us know what you would like to see for our 1000th episode, because that will be coming up in, I don't know, 12, 15 weeks, something, depending on shows, holidays, etc. But yeah, okay. Let's do the end of this show so we can all have a good night's sleep and Justin can get off to a good day. So, yeah, thank you everyone for joining us for this episode. All of you in the chat rooms, YouTube, Twitch, Facebook, Discord, wherever you are, thank you for joining us. All of you listening to the podcast later, thank you for joining us. Fada, thank you so much for helping with show notes and social media, and I will be in touch about getting us an appointment very, very soon. Yes, I know. Gord, Arnlore, others, thank you for keeping the chat rooms nice, happy places to be. We like to be good to each other and say nice things so everyone feels welcome. Rachel, thank you for editing the show. Identity4, thank you for recording the show. And all of our Patreon sponsors, thank you for being our Patreon sponsors. Thank you to Eden Mundell, Alan Viola, Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Street Smith, Richard Batch, Bab Coles, Kent Northcote, George Corris, P.L. Velazarb, John Rajaswamy, Chris Wozniak, Vegard Sheftar, Donathan Styles, DK, Don Stylo, Ali Coffin, Bragan Shubu, Sarah Forfar, Don Mundus, P.I.G., Stephen Arbon, Daryl Albaran, Daryl Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Marcus Flo, Steve Leeson, aka Zima, Ken Hayes, Howard Tan, Christopher Reppin, Richard Brendan Minish, John Gridley, Remy Day, G. Burton Lattimore, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Phillips, Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, Lon Makes, EO, Adam Mishkan, Kevin Parachan, Aaron Luthen, Bob Cardler, Marjorie, Paul D. Disney, David Simmerly, Patrick Ferraro, and Tony Steele. There was a lot of mushy mouths in my talkings of names tonight, but thank you, all of you, for your support on Patreon, and all of you who would like to be Patreon supporters and have your name mushy mouthed, please head over to TWIS and click on the Patreon link on next week's show.
We will be back Wednesday, 8 p.m. Pacific time, and Thursday, 5 a.m. Central European time, broadcasting live from our Twitch, YouTube, and Facebook channels.
Do you want to listen to us as a podcast? Maybe while you write an email that you're going to save for later after a good night's sleep. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes and links to stories will be available on the website, www.twis.org. And you can also sign up for our newsletter.
We love your feedback. If there's a topic you would like us to cover or address, or a suggestion for an interview, please let us know on one of our social media accounts. You can find them. Or send us an email. That's probably the best option. Just be sure to put TWIS, TWIS, in the subject line, or your email will be slapped into oblivion.
We look forward to discussing science with you again next week. And if you have learned anything from the show, remember,
it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the
We rarely represent anyone's views but our own. If they happen to coincide with your own views, then that's fantastic. Hi. Tired Blair, thank you for staying late. Sorry.
That's okay. I'm gonna
Everybody.
view the inside of my eyelids right now.
Yes. Everybody, thank you for joining us for this episode that went forever and a day. But it's only been 2.5 hours. La la la. Thank you, Gary. Oh, Robert Varner stayed awake for the whole show. Woohoo! Father will miss you and all the aminals, he says. I don't know. Kyle Petit says, have a beautiful time.
Will do.
Paul Disney, we will miss you, Blair.
Miss you guys.
I miss
Maybe I'll be in the chat room.
Oh, that would be nice if you could be in the chat room, but you don't have to be. Do whatever you want to do. Whatever works. Yes. Oh, I have. Yes. Extra long show. time for bed now.
Yeah.
Yeah.
I guess say
But
goodnight
I don't
to
know where
Justin for me.
I know. I don't know where Justin went. We want to
'Cause
say
I
goodnight.
cannot chill.
I'm like, hey, we gotta say goodnight. We're just gonna hang up without you, and then that's weird.
Say goodnight, Kiki.
I know. Is he gonna run in here? I don't know. Yes. Nope, he's not running in.
No.
There we go. It's all in my head too. Awesome, Gary. Let's see. Have a great science week, everyone. Yes, Fada. That's a great, yes, it's what everyone should do. Okay. Yeah, good. I hope we give you great dreams, Kyle. Yes, weird things to dream about thanks to TWIS. I hope your dreams are not full of slap fights, but more so help you deal with the decisions you need to make in life. Okay, I was giving Justin a little bit extra time, but that's not happening. So, yeah, Blair, let's keep in touch. Don't be a stranger. I miss you. I hope we can make something happen in the next 9 weeks, but yeah.
I think so.
Yeah. Okay, I don't know where Justin went. He's not coming back. So, say goodnight, Blair.
Good night, Blair. Say good night, Kiki.
Good night, Kiki. Good night,
Good
everyone.
morning, Justin, wherever
Good
you are.
Yeah. Good morning, Justin. Good night, everyone. Oh, there he is. Say good night. Say good night, Justin.
Say good night, Justin.
I can't.
Say good morning,
Sun's out.
Justin.
Sun's out. Good morning, Justin. Say goodnight, Blair.
Man, you came in so hot with your audio. Good night, Blair.
Because it's the morning. My testosterone is up.
Sun's
I'm
out,
ready to
guns
go
out. Testosterone.
face slap strangers on the
Cooking.
train.
Okay. Good night, Kiki.
Do not do that. Okay. No slap fight. It was a good science night. Everyone, thank you so much for joining us. Thank you, Justin and Blair, for such a great show tonight. It was fun talking. And I hope everyone has a wonderful week. We'll be back again next week. Stay safe, stay healthy, stay curious, and